Continue from where we stop, you have our residual anomaly after it's been plotted with the residual data we got with our x-axis. We got something like this. So you connect all the points together. After connecting the points together, the thing that's expected for you to do is to estimate the depth of the anomaly. Estimating the depth, you need to find the half of the amplitude, which we've treated earlier in earlier videos. So the peak of the values here, so half of my amplitude, that's amplitude from the highest. The highest value here is 0, which is 0 minus peak minus lowest. What's my lowest here? 211 minus 211 over 2. So if I do this, I'll have 211 over 2, and that's like 106. So you check from the top to here, we have 106 here. That's why we said a half here is 106. So from there, you're going to extend it to the x-axis and you get your x1 and your x2. Good. Now, to find your half width, which is given as x2 minus x1 over 2. So x2 here, you find it increment by 2 to 2. X2 is equal to 14 plus 14, and x1 is equal to negative 14. So you see 14 minus 14 over 2 is equal to 28 over 2, and that's what? 14 meter, because your x is a meter. So 14 meter. So with that, what we have here is a magnetic ball. We said that assume the geometry is a sphere. Assuming the geometry is what? A sphere. So since what we have a metallic ball, we can assume that the geometry is spherical. Balls are always spherical. So with that, we use this z is equals to 2.5 x half, which is pertaining a depth estimation pertaining to sphere using the half width method. Note, half width method is when we try to guess about sphere and cylinder and the rest. But for Peter's slope method, we try to use the thin. Okay, most time we use the thin, but thick, thin, intermediate, those are, we check the like thickness. We use the thickness method to try to solve for our depth. So with that, we got 14 is our x half, and we got 35 meter. So based on the anomaly, based on the residual anomaly that we have here, given here, based on this residual anomaly, so the residual anomaly is gotten in a location where it is the latitude. 0 degree is a nice value, but most time I like to give it in a range between 0 degree to 15 degree. We have anomalies looking like this. Okay, like the cup shape anomaly. Okay, the cup shape anomaly, something like this. So exactly like this. So there are lots of anomalies, and these are depending on locations. So that's how we get our data. So we've interpreted this anomaly, we've interpreted this data. I mean, we found the regional residual in the previous video, and now we are seeing how to find the depth, the estimation to the depth of the anomaly. We've come to the end of the video, and one thing I want you to do is to keep practicing over and over again and get used to it. Okay, have a nice day. Stay tuned and share my video to your fellow friends. Thank you.